Lanzarote is really a unique place to make and to perform analysis related with planetary geology and astrobiology, and for understanding the processes which take place in other planets and in other moons. Lanzarote shares very important things which also occurred in the past on Mars. Mars was wet in the past, and this was crucial for understanding the paleoenvironments and also the possible existence of life.
We are going through a sequence of different and with an increasing level of difficulties traverses, taking into account one specific area where we have spotted some scientific questions from satellite images, and then we want the astronauts to try to solve them through their sampling and observations on ground.
Steep slope, I would estimate around 30 degrees.
The first step for planning a geologic traverse is to characterize the geology of the site from a broad view, and this is possible by analyzing satellite images.
We started with Caldera Blanca, which was the first traverse. Very nice calderas and different phases of eruptions, interactions with water, which is one of the main topics related to the, for example, search of life on Mars. Then we went also in a lava tube, so one traverse was underground in a tube made by a lava flow, and this was to understand how this structure forms and how they evolve and which kind of weathering we can find in them. And this is another important planetary topic. Then we went through Tinguaton. The Tinguaton area, it's another volcano, the most recent volcano here in Lanzarote. There is a direct interaction between the water on the ground coming from the sea and the magma flowing out on the surface. Today we are here in Los Cricos. It's the last traverse, is the most difficult one, because this area is extremely complex, even for a geologist. It was an increasing in difficulties and of interpretation, but the method is the same for all the traverse, and it's to get the most of the information, observations and samples, the right samples from the right place, and the right informations related to the samples.
Sampling is a very important procedure which should be made very accurately, because when the sample will be back on the Earth, will be studied for years by the scientists. If you think that Apollo samples are still studied after 30 years, the sampling should be smart enough to characterize all the landscape and also to pick the out of context possible rocks.
This looks a lot like what it would be in Mars. When they go through a traverse, they analyze the geological landscape, they describe the landscape to the scientists, they identify interesting sites, they change their plan according to what they discuss with the scientists, they sample, they bring back samples, and then they analyze on ground. And this is really how the course was constructed, bringing step by step the astronauts through this exercise of becoming more and more autonomous and less dependent on the scientists that they were guided by.
seconds.
Another
0.6 decimal 6 seconds.
Another option is
So in general, when we think about exploration, space exploration, we think about settling down on the surface of a planet, of a celestial body of sorts, maybe a meteorite, maybe a satellite, maybe an asteroid or a planet, and then do exploration, trying to figure out the history of this body. In order to do that, there needs to be an understanding between those on the field, those on the ground, and the scientists. They may not be the same people that are doing the exploration. So the explorers need to have some tools. Sometimes the tool needs just to be communication. They need to understand what they're looking at. They need to know how to communicate their observations to the scientists that ask the questions. And that's why a course like this is important. Not because I will be going to Mars or to an asteroid, but because now through courses like this, we can combine our operational experience with the teaching experience of our instructors and come up with the way to instruct the future explorers to do this.
The astronauts, when will survey other planets, they will be not with scientists, so they have to learn how to communicate with scientists, and in the meantime we have to learn how to interpret their language when they are describing geological landscape and when they are describing geological feature. Since the astronauts will be our eyes and our hands on the other surfaces, we should be very well coordinated.
All the samples that our astronauts are taking will then be used back by the scientists who will create theses for the students. The traverses that we're using now with the astronauts will only be used by the scientists up to the moment when they know everything that they can learn from this site, from a geological perspective. And then they will look for other traverses. So what was built just as a training is becoming an opportunity for science and also an opportunity for education.
The benefit that we're trying to obtain from this course is the fact that when we put together the scientists that in the ground will do the final studies and will do the scientific interpretation, and the astronauts who will go there, if we put the two groups together and make them work together, we'll find a method by which they will work better together, by which one should learn from the other at least a minimum such that they can communicate. And by that we hope to obtain a basis on which to organize the exploration trips once they happen.
by another.
I took one from the red part. Well, I have to take a picture of it, and you need the name of it.
In the place?
This place? Well, no, that's okay. But
I was preparing this big.
So far, only the Americans have trained astronauts for landing on a planetary surface. These were the Apollo astronauts, and that was 50 years ago. So far, like Europe, has not been involved into preparation and training of astronauts for going on a planetary surface. But Europe wants to go to the moon, and later on Europe wants to go to Mars. So we need to start preparing astronauts for these missions, and that's what we're doing now here. The astronauts are the technicians on the ground that need to work for the scientists here on Earth. So far we have expert knowledge in Europe only with the geologists. The astronauts only have knowledge on the operations side. Both sides need to work together to develop a concept so that it can be run operationally on the moon, on the Mars, but it also needs to satisfy the geology needs. So the scientists need to get the most out of it.
doesn't get hit by the flow of water. Geological field training is one step towards exploration. What it means is that when we think about exploration, we are not satisfied as humans just by seeing robots or rovers collecting a sample and sending us the data. When we think about exploration, we want to see the footprint. We want to see the sand in the gloves of the astronaut, and then we will know that we have explored the planet. And in order to do that and to come back with knowledge, come back with science, come back with something that we can use to better understand our place in the universe, we need astronauts with competence about what they are observing.